and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is question number 2.52 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's check the question. Following results are observed when sodium metal is irradiated with different wavelengths. Calculate threshold wavelength and Planck's constant. So here they gave wavelength in nanometer. Now we convert this nanometer into meters. How? 1 nanometer is equal to 10 to the power minus 9 meter. So we will multiply nanometer with 10 to the power minus 9 meter. So same we will do. 500 nanometer is equal to 500 into 10 to the power minus 9 meter. 450 nanometer, 450 into 10 to the power minus 9 meter. 400 into 10 to the power minus 9 meter. So these are the wavelengths in meter. Now next thing, they gave the velocity of the photon. They gave V into 10 to the power minus 5 centimeter per second square. So we need to do this 10 to the power minus 5 will go with the given values in the division form, first thing. And second thing, centimeter per second will change to meter per second. Let's see how. So this 10 to the power minus 5, when it goes, so it will be like V is equal to 2.55 upon 10 to the power minus 5. So 2.55 into 10 to the power 5, it will become like that. And later on 2.55 into 10 to the power 5 into 10 to the power minus 2. This minus 2 comes from because 1 centimeter is equal to 10 to the power minus 2 meter. So 10 to the power minus 2 will add. So total the value becomes 2.55 into 10 to the power 3 meter per second. In this way, we will change all the three values of velocity. So 2.55 will become 2.55 into 10 to the power 3 meter per second. 4.35 into 10 to the power 3 meter per second and 5.35 into 10 to the power 3 meter per second. Understand? This 10 to the power 5, 10 to the power minus 5 from multiply it with velocity, we will go with the numerical value and it becomes 10 to the power 5. That 10 to the power 5 when totally converted to meter, again 10 to the power minus 2 is added. So 5 minus 2, it becomes totally 10 to the power 3. So now we have the values of wavelength and the velocity. We need to calculate the threshold wavelength, that is lambda naught is not known and Planck's constant is also not known. We need to find this too. To find lambda naught, we have the value that E naught is work function. Work function E naught is equal to hc upon lambda naught. So using this formula, we will calculate the wavelength, threshold wavelength lambda naught. But before that, we need to calculate the work function. For work function, we have the formula work function E naught is equal to energy of the photon minus kinetic energy. So one formula is this and the second formula is this. First we calculate the work function. If we get the work function, then we will put in the equation number 1 and we will get the threshold wavelength. This is equation number 2. So equation number 1, we will start from equation number 2. Work function is equal to energy of the photon minus kinetic energy. But again, we don't know the energy of the photon and the kinetic energy. For this too, we need to calculate the energy of the photon. Because energy is equal to, we have one more formula, E is equal to hc upon lambda. And lambda is given. When lambda is given, we have three values of lambda. It means three values of energy of the photon we will get. Again, and for kinetic energy, how to calculate kinetic energy? Our formula is 1 by 2 mv square. So velocity is given, m is the mass of the electron So from here we will calculate the kinetic energy. So we will start with the energy of the photon. Let's see. Since we have three values of lambda, we will get three values of energy of the photon. So first value is, we can say E1. It should be hc upon lambda 1. H is 6.626 into 10 to the power minus 34 joules second, into c is velocity of light 3 into 10 to the power 8 meter per second, which in turn divided by lambda 1, and its value is given. Lambda 1 value is 500 into 10 to the power minus 9 meter. Now start doing the calculation. Meter cancel out, per second cancel out, and we'll multiply 6.626 into 3 divided by 500. We will get the value 0.0397 into 10 to the power. Now minus 34 into 10 to the power 8 into 10 to the power plus 9, it becomes minus 9 from denominator will become plus 9, and now the answer is 0.0397 into 10 to the power. Now minus 34 plus 17, it will become minus 17 joules, and we can shift the decimal to get the more appropriate value. It will be 3.97 into 10 to the power. So again we shifted 2 steps. Right one means minus 2 is added. Minus 17 minus 2 become minus 19 joules. This is our E1, energy of the photon with the given first wavelength. In the same way we will calculate E2 and E3. E2 will be same, 6.626 into 10 to the power minus 34 joule second into 3 into 10 to the power 8 meter per second divided by lambda 2. Lambda 2 is given here 450. 450 into 10 to the power minus 9 meter. Again when we calculate, so after doing calculation, our value for E2 will be 4.42 into 10 to the power minus 19 joules. This is our energy of the photon in terms of lambda 2, lambda second value. In the same way we will calculate E3. Again hc upon lambda 3. H is 6.626 into 10 to the power minus 34 joule second into c 3 into 10 to the power 8 meter per second upon lambda 3 is 400 into 10 to the power minus 9 meter. If we do the calculation, we will get the value 4.97 into 10 to the power minus 19 joules. This is the value of energy number 3. So in same way we will get E1, E2 and E3. Here is our E1, here is E2 and here is E3. Now next thing is we need to calculate the kinetic energy. Let's start the kinetic energy. Ke is equal to 1 by 2 mv square. So we have v means here velocity, m is the mass of the electron. So velocity is given 3 times in 3 different observations. So same we will get 3 values of kinetic energy here. So Ke1, it should be 1 by 2 into 9.1 into 10 to the power minus 31 kg, because mass of the electron is 6, it is 9.1 into 10 to the power minus 31 kg into v square. Now first velocity is given 2.55 into 10 to the power 3 as we calculated meter per second, and here in the formula square. Now expand it and calculate will get the value 2.96 into 10 to the power minus 24 joules. This will be our calculated result. In the same way, we will calculate K2 and K3. K kinetic energy 2, it will be 1 by 2 into 9.1 into 10 to the power minus 31 in kg into, now V2, velocity number 2 is 4.35 into 10 to the power 3 meter per second square, and we'll get the value is 8.61 into 10 to the power minus 24 joules. Next comes kinetic energy 3 for the given velocity. Third number, that is again 1 by 2 into 9.1 into 10 to the power minus 31 kg multiplied by given value is 5.35 into 10 to the power 3 meter per second square. From here we will get our answer. It will be 1.30 into 10 to the power minus 23 joules. So in this way we will get three values of kinetic energy. Now when we have three values of energy of the photon and three values of kinetic energy, again we need to we need to calculate the work function. So work function, as I already told, work function E naught is equal to energy of the photon minus kinetic energy. So if we have three values of energy and three values of kinetic energy, we will get again the three values of work function. So we can write E naught 1 is equal to, now we will calculate in the same way. E1 is, write the value of E1, its value is 3.97 into 10 to the power minus 19 minus kinetic energy 1. Kinetic energy 1 is 2.96 into 10 to the power minus 24 and joules. So as we can say, the value is very small because the exponent is in minus, so the value is very small. So when there is very small value, the difference between the two values is negligible, it won't be visible. So we can assume the answer should be approximate to the energy. 3.97 into 10 to the power minus 19 we will take approximate value because the difference is negligible. In the same way, we will get E naught 2. The E naught 2 is should be, this is E1, sorry, this is E naught 2 means E2 minus kinetic energy 2. So E2 value is, as we calculated, 4.42 into 10 to the power minus 19 joules minus kinetic energy 2 is 8.61 into 10 to the power minus 24 joules. So the difference again, because the value is in negative exponent, so difference will be negligible. So we will take the value of the energy, that is 4.42 into 10 to the power minus 19 joules will be the work function 2. This is not the equal approximate value. In the same way, we will calculate work function 3. It will be E3 minus kinetic energy 3. So E3 value is 4.97 into 10 to the power minus 19 joules minus kinetic energy 3 is 1.30 into 10 to the power minus 25 joules, and the answer is approximately to the energy 4.97 into 10 to the power minus 19 joules. So in this way we will get the three values of work function here. Work function 1, work function 2 and work function 3. In this three work function will take for the further calculation or for the preferred wavelength we will take the value of work function 3 because it is the maximum in this three case. The work function 3 is 4.97 into 10 to the power minus 19. This is the maximum. Why will get the maximum value? Because maximum work function is required for the minimum energy to eject the electron. So we need to eject the electron with minimum energy. We should take the maximum work function. So here we will going with the work function 3 and will put in the formula. Which formula? Formula was work function is equal to hc upon threshold wavelength. Now here in this formula we will get the threshold wavelength. So from here threshold wavelength is equal to hc upon work function. Work function value we will get the maximum, that is 4.97 into 10 to the power minus 19. Same H is 6.626 into 10 to the power minus 34 joule second. Into C value is 3 into 10 to the power 8 meter per second, which in turn divided by work function 3. Work function 3 is the maximum value of work function. So 4.97 into 10 to the power minus 19 joules. Now multiply 6.626 with 3 and divide it 4.97 will get the value here 3.999. Now powers are into 10 to the power minus 34 into 10 to the power 8 into 10 to the power 19. So 19 plus 8 we will get 27. So 34 minus 27 will get 7 only. That will be in minus form. So we will get 3.999 into 10 to the power minus 7 joules. Not joule, sorry, joule and joule cancel out. Second and for second cancel out. Meter is left over. Meter. So we can write it 3.998, it will be 4 into 10 to the power minus 7 meter. That is the threshold wavelength. Or we can write in terms of nanometer. If we do 400 into 10 to the power minus 9 meter, we can write it 400 nanometer. This is also the threshold wavelength in terms of nanometer. So this is our answer number A, threshold wavelength. Now next part of the question is find the Planck's constant. We'll use the same equation. Work function E naught is equal to hc upon lambda naught. So from here, if we say separate the h, so it will become E naught into lambda naught upon C. Substituting the value, E naught value we have taken 4.97 into 10 to the power minus 19 into threshold wavelength we get here 4 into 10 to the power minus 7 meter upon, this is joule, this is meter, 3 into 10 to the power 8 meter per second. Now meter and meter cancel out. Calculate the values, we will get the answer here 6.626 into 10 to the power minus 34 and the unit will be joule per second. And this is the value of Planck's constant. So friends, this is the calculation for the second part of the question. So friends, calculation is lengthy. It's not difficult. So do stepwise process and you will be able to get the answer. So keep studying, keep asking the question. Don't forget to press the bell icon. Till then, thank you.